Hello everyone. Today I come up with one topic which is in the syllabus of emerging technologies, computer fundamental emerging technologies. This is one of the famous topic nowadays because as you see that there is a lot of boost towards the latest technologies which are based on data. So this is one of the technology which is basically there to assist the businesses to take decision based on the data. The name of the technology is big data analytics. So before moving to this, first understand that what exactly the difference between analysis and analytics. So analysis is basically the looking at the historical data and seeing the representation of that historical data is analysis, and doing the analysis based on what has happened. While in case of analytics, so what is analytics is basically keeping historical data in mind, and finding out trends in that data and pattern and doing some future prediction out of that data is the analytics, right? So that's the thin line difference between analysis and analytics. So let's move ahead on this topic itself. What does big data means? So first understand about big data and then we will move to the big data analytics. So what is big data? Big data is a massive set of unstructured, semi-structured data from the web traffic, social media, sensors. So these are the sources to generate this big data, right? So big data is basically either can be in a form of structured or semi-structured, right? It can be produced from the web traffic, social media, sensors which are deployed on the field, IoT sensors. We are talking about IoT sensors here, right? And the size is extensively very high, right? Petabytes, exabytes of data. It's the big data, right? Volume is great, right? Which is not there, it's great for the typical DBMS. So if you compare the typical DBMS data and the volume of this data, so there will be a lot of difference in that. So it will be huge. Information from multiple internal and external sources, right? Transactions which are happening in any systems, social media, right? Social media interactions, right? Enterprise content, right? Sensors, the data of sensors, mobile devices, the data from the mobile devices, all this comes under, these are the sources of the data where this big data is being collected, right? So let's take statistics here, right? In the last minute, when I was talking about this slide, so what has happened is, so it's approximately figured 204 million emails would have been sent, right? And 61,000 hours of music listened on Pandora, right? 20 million photo views would have been there in different platforms, right? These much of tweets, right? 6 million views and these much of Facebook logins, right? Has been happened. Just we were talking about we are talking in the last minute, and then this data is being generated. 2+ million Google searches, right? So everybody is going to search something on Google to clear their doubts. Some query is coming in their mind and they are searching on the internet, right? Doing some R&D, referring some previous research, right? So all this is happening through this Google searches. So in last minute, while I was talking about this big data, these things has happened, right? 3 millions of uploads on Flickr, right? So this is the humongous data which is right now being generated in just 1 minute while we were talking. So this is big data, right? I hope you are able to understand the concept behind the big data analytics. So we were first understanding what exactly the big data is, right? And these are the important aspect to understand the big data analytics technology. So we started from big data, how it is and how we view it, how we can think about it, right? What are the parameters it should contain, right? and then we will move towards the characteristics of the big data. Correct. So big data characteristics. So the voluminous data which just has been created, in the last, when we are referring the last slide, what are the characteristics of that data? That data is growing by quantity. So means growing by quantity means it would have a video content, it would have a behavioral aspect where people are commenting about any topic on the social media platforms. So social media interaction is there, and speed of that data is very high. So you can take an example of the smart meters. So in India, I would take example here. In India, we usually have the meters where the readings are being taken by the readers who are working under the government organization and maybe in the private organization, and they are taking the readings from the electronic meters periodically. But in the countries like US, there are smart meter who are actually pushing that data, that energy consumption data, to the head-end systems, and then those head-end systems are there to react on basis of or generating the bills based on the uses with the help of the billing systems, right? So this is how the automated process is happening here. So why I'm taking this example, because I have worked on one of the project where there are the smart meters who are pushing continuously data in every 30 hours. What type of data? Energy data, means the energy parameters like kWh, kVRH. So all these data is being pushed by these smart meters periodically in every 30 minutes. So think about the rollout of a smart meters in US. So how many smart meters would be there? So lot of, right? There will be a lot of smart meters. Now what happens is all those smart meters are pushing data to the head-end system periodically. What kind of volume that data would have? So it would have a very high speed of data which we are getting, right? Volume is also high, right? Speed is also, velocity is also high, and type of data, variety. So these are the three parameters which you can say are the characteristics of the big data. So these three characteristics: volume, variety, and velocity, we have seen, right? Variety can be a text data, can be a video data, right? Anything can be structured data which you have referring for your enterprise application. So all these set of data and having these possible three characteristics will fall under big data, right? Let's move ahead on this. So here I have given you a few examples of the volumes, right? Volumes in terms of the size, petabytes, exabytes of data is the voluminous data, the representation of the data in terms of the size of the data, right? And which is typically very great for the DBMS, means very high for the DBMS systems, right? It has most of the companies in the US have at least 100 terabytes of data with them. So this is the parameters which is this is the parameter which is talking about the volume, right? Now let's move ahead about the velocity. Now the velocity, New York Stock Exchange captures 1 terabyte of trade information. So even it is true for the Sensex in India also, right? The Mumbai Stock Exchange, right? Nifty. You can talk about any trade, platform. So there are a lot of information which is, in terms of transactions is happening, and the velocity is very high. Every time there is buy and sell is happening on those stock exchanges. Modern cars have close to 100 sensors. So we are trying out the driverless cars also, right? So there are a lot of sensors put in there. Even in the not the driverless cars, even the high end cars have the lot of sensors which are being put in those cars, and those sensors are sensing the phenomenon, right? The phenomena they are measuring. So it has lot of data. So that data is coming to the system for the analysis, right? So the velocity of that data is very high, right? Network connection. So in 2016, it is projected that there will be 18.9 billion network connections. So it shows the the velocity, how much the data, looking at this characteristics velocity will look like. So it's a massive amount of streaming data, right? This is the second characteristics of big data. Now, third is variety. So in 2000, as in 2011, the global size of the data in healthcare was estimated to be 150 exabytes. This is only the health data which we are talking about, the global size of the healthcare, right? So the variety, massive set of unstructured, semi-structured data from the web, right? Social media, sensors, and so on. Variety of data which we are getting. 30 billion piece of content from the Facebook, right? 4 billion hours of video from YouTube. So you are continuously seeing this kind of big data is being generated, where the people are engaged, putting their time and engaging with the video content. That content itself is having a high volumetry data which is being generated by a lot of the companies, lot of the individuals, right, who are using that platform, right, to engage the people. So lot of things. Tweets is one of the greatest example of having lot of data which is being created, and it is contributing the source of the big data, right? Now let's come to the definition of big data analysis. We understand about big data, how it is, what are the characteristics, right? Now let's move towards the big data analytics. What is big data analytics? Big data analytics is a process to extract the meaningful insight from the big data. So my back on my part. So this is big data actually. It should be big data. And then what we are trying to infer from this big data is to find out the hidden patterns in this big data, right? Unknown correlation between the data, right? And unknown market trends, or known market trends maybe, which are not even known to us, but we can have some good predictions about those market trends and the consumer preferences from that data. So we are getting humongous data from the different sources like tweets, social media engagement, the video engagement of the people, and then we are inferring that data for searching out some hidden patterns out of there, to know the customer preferences, to know the market trends, right? And that falls under big data analytics, right? This is the pure form definition of the big data analytics. Now, what type of big data analytics you can think of? It can be a structured data, big data analytics on structured data, big data analytics on semi-structured data, and big data analytics on the unstructured data. So these are the big data analytics types, right? Based on the data source from where we are inferring those patterns, those hidden market trends, user preferences, right? So the data is categorized into three parts, right? Structured data, semi-structured data, and the unstructured data. Now let's move on towards the structured data. What does it mean? Structured data refers to the data that has a proper structure associated with it, right? As you can see on this table, this table itself is a form of a structured data, where looking at this structure, you are able to infer the information that this table must contain the employee ID, name, gender, department, salary, and the first employee has the employee ID number 2365, and the name of that employee is Rajni. So you are able to infer, very easily. So it has a structure in the form of table and rows, you can say, right? For example, the data that is present within the database, you can say is example of the database like MySQL, Oracle, SQL Server. You take any example, right? You will find this sort of data there, right? Either on the CSV files. So CSV file are just is secondary form of the Excel, you can say, where the data is arranged in the comma separated values, right? As a form of comma separated values. So CSV file is another example. So the structure, right? What it contains. So Excel spreadsheets is also example of the structured data, correct? Now these are the examples of the structured data, right? And this data can also should have three qualities which I talked, right? Variety, velocity, and volume. If the structured data which falls under this set of categories, then it is a big data, and there are the opportunities to analyze that data, even it is structured, right? Correct. Now next is semi-structured data. Means it has a structure, but seeing it from your naked eyes, you cannot infer that information very quickly. So as an example here, the XML format of the data is there, right? It has some structure, right? Started from this node REC and ending on that node. Have some nodes like name and sex and age. All these are the formulated as a structure, but looking at this, a layman cannot understand what exactly the meaning of this data is, right? So this is semi-structured data. For example, the data that is present within the emails, the log files. So when we build the software systems, we do logging that what exactly what step the software has performed to while the user was interacting with the software, or any other process which is working in the background is doing, right? So we keep things in log files, right? The Word documents, like in the XML documents, you can say all those are the semi-structured example of the semi-structured data, right? Now the third is unstructured data. So unstructured data that does not have any structure associated with it at all. So for example, the image files, the audio files, and the video files, you keep adding on video files. There is no information. It's a video file, but who referred, who was using that, for which user this file belongs to. This kind of information you will not find there, right? It's just a video file. You have a collection of video file, lot of data files, and all those data files are referred from one place to another place. So this type of mess is being created. So you do not have any structured way to find out any information, while looking at that data, right? So this can be in the form of audio. It can be on the form of images, can be on the form of videos, right? Comes under this unstructured data, right? So what we have learned so far, we have learned that we are understanding here the big data analytics. Then we understand what is big data. We understand that when I was discussing the first slide on that moment only, within that minute, a lot of big data is being generated. What are the characteristics of the big data? Three characteristics, right? Volume, variety, and the third one is, I just forget that. The third one is, let's move back on this, velocity, right? And then we understood about the types of the big data analytics. So big data analytics is the way to find the patterns from this type of data, which has these three characteristics: volume, variety, and velocity, right? And then the types of the big data analytics is whether you can perform that on the structured data, semi-structured data, or with the combination of all these data sources, even in the unstructured data, right? So these all things comes under these type of sources. Meaning big data analytics is based on all these type of sources. Now we understood about the structured, semi-structured, and the unstructured data, right? In the structured data, is a typical DBMS system is the example of the structured data, but it should have the three qualities which should be available with that data. That is again the velocity, the volume, and variety. Same with the semi structured data. It has some structure, but you cannot understand that from your naked eyes. Then we understand about the unstructured data, right? Now let's move ahead on this. What's the process of big data analytics? That's the important part here. We understand about the big data. We understand about the characteristics of the big data, and what are the types of the big data. Now we have the underlying sources of the data now, which is satisfying three important characteristics, right? That is volume, variety, and velocity. Now we have that underlying source. Then what's the process to do the big data analytics? This is the process: case study and evaluation. So let's evaluate about any case study you want to build. Let's suppose you want to understand the consumer behavior while buying any household item. Can be one example, right? So that's a case study, and you evolve that study based on brainstorming, based on the circumstances where you are operating in, your business is operating in, right? Then identification of the particular data. So what data would you would be require for making sense out of this case study, right? Now that filtering of data is important. Filter that data. Every data is not important, so filter out the important data, right? Data extraction, then extract that data which is important for you, right? After filtrations, provide do multiple rounds of filtrations, based on different conditions, and then extract that information, right? Then aggregate that data. Every data solely independently not meaningful, right? So aggregation, based on counts, based on average, based on these set of things you can apply on that data, and then visualize that data on the different tools. So you can take an example of Tableau. Tableau is one of the greatest tool to visualize that data, and then data analysis. Based on that visualization, you do the data analysis. That is there any trend which is falling? Looking at the historical data, when you have plotted it through the visualization tools, right? You are seeing that can any significant pattern I'm seeing out of that data. So that type of analysis you do in this step, right? Then the final analysis, which build your theory to take more decision or have some decision for your business, for any business to grow, looking at that data analysis, and then final analysis, and then results, publishing that result, that what is the outcome, what are the decision you have taken, and making some result out of it, right? So this is how big data analytics works. I hope you're able to understand it. Thank you so much.